Devang Shah from Engg Institute of Engineering and Technology. Right, we are learning about the subject basic electrical engineering. So in our last session, we have discussed about the Norton theorem. In our today's session, let's discuss a new theorem. That theorem we define as the superposition theorem. So basics of networks we will again quickly discuss. Thevenin theorem we have already discussed. Norton theorem we have already discussed. So in our today's session, we are going to discuss about the superposition theorem. Two more topics, those are related to the circuit analysis. One is called nodal analysis and another one is called the mesh analysis. That part we are also going to learn. Now you can see here the basics of the network. So what is a circuit? Again, the path through which current flows or intend to flow is defined as the circuit. So this is example of circuit. So this is a complete circuit having the two loops, right? Now here, what is a node or junction where three or more than three branches are connected, or two or more elements are connected together is defined as the node. So this is example of node. You can also consider as a branch where a part of circuit or network which lies between two nodes or junction. For any wire, if elements are connected, let's say one single component or element is connected, or more elements are connected in a series. So this is defined as a branch. So you can see all these three branches or maybe more branches you can incorporate in a circuit, right? Same way, what is a loop? So ultimately, closed path in a network or in a circuit is defined as a loop. So you can also consider it as a mesh. So ultimately, everything depends on the current. Where current must follow the closed path, that is defined as a circuit or loop. Right now, let us quickly discuss about our next theorem, which is called a superposition theorem. Right. So here we already discussed Thevenin theorem and Norton theorem. Where why we are learning this theorem? These theorems are called circuit theorems because there are various ways. So this is one of the way. This is one of the method to solve or to analyze the complete circuit. So once you design the circuit, then in circuit there are so many number of resistors, voltage sources, current sources are available, and you have a voltage drop across a specific resistance or current which is passing through that particular resistance. You can be able to find by any method. Either you can go for a Thevenin method or Norton method, or next is the superposition method, right? So it is used to solve the electric circuit which have more than one energy source, right? So here in this circuit we have a more number of voltage sources and the current sources, right? So it is applicable to only a linear circuits. So this is obvious things where only a resistive network you can apply the superposition theorem. Same way, therefore, it is not applicable to circuit which have non-linear components or non-linear devices like diodes, transistors, etc. Right? Same way, if you define here, this is the circuit of the superposition theorem where there are two voltage sources are available, three resistors are connected in series and parallel combination. So, statement is that in a linear bilateral network containing more than one energy source, the resultant current or EMF flowing in this element can be found by considering each source separately, while all other sources are replaced by their internal resistance and then algebraically ending currents EMF or due to the individual sources. So what does it mean? In this particular network, there are two sources, two voltage sources are there, and let's say I want to find the current which is passing through resistance R2 or voltage drop across R2. So what I have to do, I have to consider the effects of both E1 and E2, right? So once you consider both the effect E1 and E2, right, on a specific resistance R2, right? Simultaneously you cannot take two voltage sources together, right? So what you have to do here, you have to take first effect of E1, then you have to calculate the effect of E1, then you have to take the effect of E2, and then you have to calculate the effect of E2. Then, and finally, you have to algebraically add or subtract this two effects that is passing through resistor R2 or voltage drop across R2, right? So superposition, that means at a time only one source you have to consider. So at a time only one source is at the supreme position, right? And that time it is acting in a circuit. That's why this is considered as a superposition, right? Let's discuss one by one. So you can see here the example where there are two sources are available. One is the voltage source, another one is the current source, and two resistances are available, are connected here. So where your job is to find the voltage drop across 9 ohm resistance or current passing through the 9 ohm resistance, right? So how you can find the effect of this two separate sources, like one is voltage source, another one is the current source. So basic method is to take one at a time, right? So let's first consider 3-volt source. So what you have to do, you have to make the current source zero. Current source zero, that is current source, you have to make it open. So once you make any current source open, that means value is zero. And that is, if you have to make the voltage source short, that means the voltage is zero, right? So here, my first job is to find from the 9 ohm resistance, I have to find the current, right? And my first job is to figure it out in which direction current would be flowing for the or from the effect of 9-volt voltage source and the 2 ampere current source. So my first job is to find the direction of current which is passing through 9 ohm resistance from these two effects. So 3-volt C plus and minus. So current would be flowing due to the effect of 3-volt voltage source from top to bottom in 9 ohm resistance. Same with the same 2 ampere current, that effect also from top to bottom. So algebraically at the end, if once you find the separate effect of 3-volt voltage source and 2 ampere current source, so at the end you have to add these two currents and you will find the answer. So we'll start with the step number 1 where 2 ampere current I make it open, so it's a 0. So your circuit is only 3-volt which is applicable to the series connection of 6 ohm resistance and 9 ohm resistance. So from that you can be able to find your current. It's very simple using the Ohm's law. So you can find your I9 dash current, which is dash stands for only single effect, and that effect is because of the 3-volt source, right? So now I9 dash, that is equal to 3 divided by 6 plus 9. So that particular current is from A to B, from top to bottom, that is 0.2 ampere. Same way, now consider 2 ampere current source where voltage source must be short or it's a 0. So now we are finding the effect of current which is passing through 9 ohm resistance because of the 2 ampere current source. So you can easily find why, because here that's a current divider rule. So ultimately I9 double dash, that is the effect of current which is passing through 9 ohm resistance from or of the 2 ampere main current source. So I9 double dash is equal to 2 multiplied by 6 divided by 6 plus 9. That's simple current divider rule. So it's a 0.8 ampere. So here for both the effect, see current directions are always from A to B in the same direction. So to consider these two effects, we have to add this currents. So total I9 which is passing through the 9 ohm resistance is I9 dash plus I9 double dash, and that is equal to 0.2 plus 0.8 is equal to 1 ampere. Right, so this is one example. Now we also discuss about the next example. Now this is the example where 2 voltage sources are available. Right, so one voltage source you have to take at a time. So if I'm going to take 50 volt voltage source, then you have to make it 25 voltage source short or 0. So once you make it short here, if you are looking from 50 volt source, then two resistances are in parallel, which is a 3 ohm and 5 ohm, and in series with the 10 ohm. So my first job is to find the total resistance of the network, right? So total resistance of that particular network is 11.9 ohm. Then the current which is supplied from the 50 volt source, that effect I have to find. So before you start step number 1, you have to think, you have to figure it out in which direction the current is passing through 3 ohm resistance due to effect of 50 volt voltage source as well as the effect of 25 voltage source, 25 volt voltage source, right? So here, as you know, the current effect or current supplied by the 50 volt source, that I define as I1 dash, and that is equal to 50 divided by 11 point the total resistance of the circuit, which is 4.2 ampere. So from this I can be able to find the I2 dash using the current divider rule. So I2 dash is equal to 4.2 multiplied by 5 divided by 5 plus 3. This is the current divider. So 2.63 ampere. That is the effect of current. That is the current which is passing through 3 ohm resistance due to the effect of 50 volt source. Then that current direction is from again A to B, is from top to bottom, right? Same way, The current which is passing through 5 ohm resistance is 1.58. So here we are looking for current which is flowing through all independent resistances. So you can see all the effect here. Now, as we discuss about step number 2, where now I'm taking the 25 volt source and so making the 50 volt source short. So same formula, but I'm now looking from this side. You can see here from this side you can looking for from 25 volt voltage source you are looking for, and you are making 50 volt short. So same here, 10 ohm and 3 ohm both are in a parallel in series with the 5 ohm. So same formula if I am using. So the total resistance for the second case is 7.31 ohm. The current would be 3.42. So ultimately I2 double dash you can find from the current divider rule, which is 3.42 multiplied by 10 divided by 10 plus 3, so 2.63. Same way I1 dash that is passing through the 10 ohm resistance, that is 0.78, right? So from this two separate example, you can find all this current I1, I2 and I3. This is the current effects, that is the current which is passing through all these three resistances, 10 ohm, 3 ohm and 5 ohm, from considering both the effects of 50 volt voltage source and a 25 volt voltage source. So you can see this, all the currents like I1 current, which is I1 dash minus I1 double dash, is nothing but two opposite direction of currents for a 10 ohm resistance. So it's a 4.2 minus 0.78, so 3.42. Same way the current which is passing through the 3 ohm, where two currents are in the same direction for both the effects. So it's a 5.26, and same the current is passing through 5 ohm resistance I2, that is equal to I3 double dash minus I3 dash. Again, two currents are in the opposite direction, which is passing through 5 ohm. From this two effects, so that current is 1.84 ampere, right? Now, one more example. Now, this example is the same example that we have already discussed during the superposition Norton, and same example now we can also solve using the superposition theorem. So, for Thevenin Norton, we have taken the same example. So, for superposition, we are also taking the same example. So, here two voltage sources, 10 watt, 20 watt, 10 ohm resistance, 10 ohm resistance, and 40 ohm resistance. Uh, we have solved this particular examples in Thevenin as well as Norton. Now, this here in superposition, we have to take one voltage source at a time. So now I am taking 10 volt voltage source, so making 20 volt voltage source short. So here, so 40 ohm and 10 ohm are in parallel with the 10 ohm in series. So you can find here that particular step. You can see here the total resistance across the 10 volt, which is at 18 ohm. The current of the circuit is zero point 0.5 ampere, and which particular current which is passing through the 40 ohm resistance, which is zero point 0.4 ampere. So all this you can find using the current divider rule. Same way, now I am taking here 20 volt source and make it 10 volt source short, right? So here I'm looking for here from from this direction. So you can see here 10 ohm resistance and 40 ohm resistance both are in parallel with the series of 10 ohm resistance. So you can easily find the total resistance for this particular step number 2 is 18 ohm. Again, the current which is passing through the 5 ohm resistance, which is 0.25 ampere, that's the total current, and from this you can be able to find I3 dash current using the current divider rule. So here ultimately current are two current directions are passing from terminal A to B. It's from top to bottom. So at the end you can add these two currents, like I3 is equal to I3 dash plus I3 double dash. So 1.28 for the case number 1, where you have taken a 10 volt source, then I3 double dash, which is the current because of the effect of 20 volt source. So both in algebraic sum you can find the total current, which is 1.68 ampere, right? So the current which is passing through 40 ohm is 1.68 ampere. Now this is the case where you already found in the Norton and Norton and Thevenin theorem. You can just check it out. Thank you very much, dear students. If you find any query, please write in a comment box.